Welcome back. This is the second lecture of Chapter 6, User-Defined Functions. So far we talked about the basic concept of what is a function. So a function is a miniature program. And function can either return values or they can be void functions. That means they do not return any values. Now, if we do return values, then the value has to be a single value. And the value of the corresponding actual parameter is copied into it. And formal parameter has its own copy of the data, what is sending to the actual function. So they're going to have their own version of their own copy of the variables, and then whatever we want to return back from the function, we're going to return that. We're going to return a copy of that value back to the calling function. So what other type of functions do we have? Well, we have a function that is using references, and the reference is passed to the function. So why would we use that, or what does that mean? Now, when we're talking about a reference, remember a variable is a named memory address. So the variable is pointing to the memory address, and the memory address contains a value. And so far, with our example, what we did, so we have that's a memory address, and the memory address is holding a value of, let's say, 15. But the address itself is, let's say, 0x5. Remember, the 0x just represents a hex value. And we are pointing to that memory address by, let's say, whatever variable we have. Okay, so this is supposed to be variable. Okay, so our variable is pointing to a memory address, and the memory address is holding a value. So far, what we did is when we sent or called the function, with the function call, let me see if we can do a new page here. Okay. So let's say we have a function and it's going to return an integer, and we have function 1, and that function 1 receives, let's say, A, and it also receives B. Okay. So in this case, if we actually have a function call, and let's call it, and let's create a main function. So here's main, and we have no parameters for main. The return value, we usually return 0. Okay. So now within main, we might have a variable, let's call x is 5, and maybe we have another one, y is 15. And at that point, from main, we're going to be calling the function 1. Remember, we're calling the function with the actual parameters. So here, I might call it with x and y. And now we have a function call. Now, what is the function going to do? The function is going to receive A and B, and let's say we're going to say int temp equals a plus b, So at that point, when the function receives A and B, then A and B is the copy of X and Y. So then we add the two values together and we are saving it into a temporary variable. And then when we're done, we say return temp. So at that point, when we return to our main function, remember step number 4 was if we have a value returning function, then we have to handle the return value. So since we are returning an integer, why don't we just store it? When it comes back, we can store it into X. Okay. So this is a simple program. So now if you look at this, what does that look like? So we have the main program, and in main we have variables that are basically just memory locations. Right? So we have somewhere in memory, we have 2 places, and one of them holds 5. The other memory location holds 15. And within our main, when we have X and Y is just pointing to that memory address, memory location. Now when we are calling X equals, let's just shorten it, and I'm going to call it F1, function 1, comma, X and Y. When we get to that point, main goes to sleep, and then function 1 is built up. So that's when you actually use up the memory in creating function 1. So here we have function 1. Now function 1 also has memory location, and the memory location is going to have, let's say, A, B, and we have temp. So A is pointing to a memory location. Now what is A going to contain? A going to contain 5, which is the copy of X. And then B, right, so B going to contain 15, which is a copy of Y. And then we're going to add the 2 values together and store it into temp. So now we have 20. So A is pointing to 5, the location of 5. B is pointing to the location of 15, and temp is referring to the location where we're storing the result of the addition. So that's the last line of code, and at that point we are returning whatever is in temp. So what we do is we take the memory location where temp is, making a copy of that value, and when we make the value of it, we're going to return and store that new value into X. So we overwrite the value of X, and now X is holding 20 after the function call. Right? So in essence, what we have here is X is linked to A and Y is linked to B. So so what does that look like, let's say in flowchart, right? So we have the start, and after the start we have declaration and function call, right? It's just one single big rectangle box. The rectangle has all this. Okay. And at that point we're just going to stop. Now the function 1 also had its own flowchart, right? So at that point the function 1 starts, and then we have a process inside, and then it returns. Okay. Let's see if there's any way to clear this. Okay, I'm getting there. Okay, so we had this function calls. Let me try to erase all this. Okay, so let's see in a little bit more detail how that looks like. Right? So we have start, and we have declaration. We declare x and y, right? So x is a number x, and we have number y, and x is 5 and y is 15. Okay. Now, when it comes to a function call, okay, then you can represent that in different ways, and it doesn't really have a standard way, so to speak. So many times when you see a function call, as far as a flowchart is concerned, you see this box, and the box has two lines on the side, and what you do is you put in the x equals function 1 and descending x and y to that function. So we know that we're going to have a function that we call, and that function will receive x and y coordinates. Whatever is returned is going to be stored in x, and at that time we're just going to stop. So that means we need to define what function is. Okay, now if it's a built-in function, somebody else's function, you don't worry about somebody else's function's flowchart. Okay, you just refer to the name. Now, if you are designing the function, like in this chapter, then you have to design the flow of that function just like you would design the flow of your application, or you want to call it the main function, right? Main is still a function. Okay. So here what we do is, if we don't start with a start, we start with the name of the function. Okay. So let's see if I can get rid of this. Okay. So we're going to say function function 1 is what we are starting with. Okay. At this point, we have two local variables within the function, which is a and b. But we received those values, right? A and b. We received those values from the function call. Now they are going to be considered local variables. Okay. And in this chapter, you guys have a really good exercise in the book about scope of the variable. You do need to look at that table and go through all the different variables and the visibility of different variables in different functions and blocks. So a and b is a local variable to function 1. Okay, and at that point, the only thing that we're going to do is we're going to have temp, and temp equals a plus b, and at that point we return temp. Okay, so our terminating shape, the terminating shape is just says return temp. Now, if it's a void function, doesn't return anything, you just say return. in your flowchart, but you do not use the keyword return if it's a void function. Okay, so this way you can see the relationship. Okay, the other way that I like to do, and I would recommend doing it that way. If I get rid of the main function. Okay, so we have the start of our program, and then we declare the variables. Okay, now if you're gonna move on and study another or take another class like Java, object-oriented programming, okay, what you're gonna be learning there after pseudocode and flowchart in this class, in that class you're gonna be learning about UML. Okay. It's a unified modeling language. So the unified modeling language uses this shape. Okay, so this is the UML type of a box. Now UML is used for objects, and that's the difference between functions and objects. So objects can stand on their own, and in Java you call it instantiating. Okay, you're creating objects based on classes. But here, the reason I like this shape, and you guys can use either one of the shapes, either one of the ways of representing it in your code. The only thing that I'm asking for is that you're going to be consistent. So if you use one type of a shape, use that shape in all of your projects. So in the UML, you have the name of the function. Okay. In the top portion, function 1 is the name. What we return is return temp. Okay, and the way that we call it is we call it with X and Y parameters, right? And the X and the Y parameters, we can show that X in function 1 is linked to A and Y is linked to B. Okay? And then that's where we're going to stop the code. Okay? So it works either way, but this still shows you that you're calling function 1 with parameters X and Y. So when you look at your function 1 flowchart, you can see that X is received, right? X is received and then B is received. Now, X is received as A and Y is received as B. It's a copy of it. Okay, so we are copying the values. Now, when we're talking about reference, we are not sending the copy of the value. Okay, what we are sending from the calling function to the called function is this. It is the memory address. It is the memory address where the value lives. So that means even though you're in function 1 and you make changes to the variable's value, when you go back to the calling function, the value going to be persistent, and it's going to be maintaining the value that it was in the function. And that's going to be the basic idea of reference variables. Okay? So the reference parameters are used in 3 situations. Remember, if you are calling a function by value, you can only return a single value. So if we need more than one value, then we have to reference the values by memory address. If we want to change the actual value, so if we want to actually change the value in the calling function, then we have to use reference. Or if we're looking at optimizing our code, we need to understand when we make a copy of this, when we make a copy of a parameter or a list of parameters, copy means take more resources. So if you do not want to take more resources, you want to save memory, and you do not have to protect the calling function's variable, then you can use reference, because reference does not make a copy of it. It's just creating the pointer to the same memory location, basically. Okay. So when a function is called, memory of its formal parameters and its local variables is allocated in the function data area. For a value parameter, the actual parameter's value is copied into the formal parameter's memory cell, and that changes to the formal parameter do not affect the actual parameter's value. Okay. Oops. Where are we? Okay. For a reference parameter, the actual parameter's address to the formal parameter is passed. Both formal and actual parameters refer to the same memory location. During execution, changes made to the formal parameter's value permanently changes the actual parameter's value. Okay? So what does that really mean? So let's say we have a function, right? And we have a value or a variable x, and x is equal to 5. Okay. Now, if we have a function, okay, let's say function 1, and function 1 going to have a variable a. So if we call this by value, okay, remember, let's represent that by a solid line, solid arrow. So if we're calling the function using the actual parameter x, the formal parameter in function 1, which is the formal parameter is a in function 1, will receive a copy of x's value. So maybe x is stored as 0x10. A gonna be somewhere else. So it's gonna be 0x, let's say 11. But the value of it is gonna be 5. Now if function 1 changes this value later on to, let's say, 15, x does not change, right? So when we do return back to the calling function, x is still going to be 5. Now what happens if we call a function by reference? So in that case, how do we call a function? With actual parameter. Now with the actual parameter, okay, let's see, let me change the color here. So let's say we have the same function. So 0x10 holds 5, and that refers to x. Okay? But x is just a reference to a memory location. So now in function 1, when we call this function, we are not sending 5, but we are sending, and what we're storing in A will store the address of x from the calling function. So what happens now? Let's say in the function you want to say a equals a plus 2. What is that going to do? Well, what that's going to do, change the value of a to 7, right? So a is referring back to x because a is a reference. So when we are adding 2 to the location where A is pointing to, you are not changing the memory address where A is pointing to, but you're following that pointer, you're following that reference variable back to 0x10, and then you're adding to it. What you're doing is you're overwriting the value where A is pointing to. Where does A point to? A is pointing to 0x10. Now if it's pointing to 0x10, X is pointing to the same memory location. So when we are returning from the function call and we're referring to X, now we really are returning and referring to 7. Okay, so that's what these few PowerPoint slides are talking about. We're calling a function by actual parameter, and now either we receive the copy of the actual parameter as the formal parameter in the function, or we receive the actual parameter's memory address as the formal parameter inside the function. Okay. Even though you're using the reference parameters, you can also return value. So you can return one value and reference a lot of values from the function, but it's not recommended. So if you are using references, make that function void function. Okay. If you only need one value back from the function, then don't use references. Use a value returning function, but don't mix the two. So by definition, a value returning function returns a single value via return statement. So don't mix the two. If you use the return statement, don't take the reference as parameters. So if a function needs to return more than one value, change it to a void function and use reference parameters to return the values. Scope of an identifier. So it's a very good exercise in your book, and make sure that you look at the code, look at the table that shows you what function actually refers to, or what function can see, and why those functions can see variables. And it's a really good exercise. It takes maybe 30 minutes to go through the whole thing. But make sure that you go through that exercise or ask questions about it, because it's a very important concept that you really need to know. So scoping of identifier, where in the program the identifier is accessible. So local identifiers are identifiers declared within a function or a block. Global identifiers are identifiers declared outside of every function. So usually you put those in front of main. So identifiers outside main and every other function are global identifiers, and global identifiers can be seen by all functions. So C++, the language, does not allow nested functions, so each function stands on its own. So what are the rules when an identifier is accessed? This is also in your book, right before the exercise, so make sure that you understand the rules. So global identifiers are accessible by a function or block if declared before function definition, function name different from the identifier, if the parameter of the function have different names, and if all local identifiers have different names. Again, it's only going to make sense if you go through that exercise in the book, and it's a really good exercise. So I really recommend that you spend some time with that. When we have nested blocks, the identifier is accessible from the declaration to the end of the block in which it is declared. So think about like the for loop. When you start the for loop, you say int I equals 0. Well, I not going to be alive after the loop executes and exits out of the loop because you did not declare I outside the for loop, but as part of the for loop. And for loop has a block it actually contains or it has the block definition by the open and close curly brackets. So int I is declared inside that block. So when the loop exits and you are outside that block, I basically goes away and you cannot access it anymore. So within the nested block, if no identifiers with the same name exists. Now, the main thing that you need to understand is, think about it like whoever is the closest one to you. Okay, so if you look at humans, right, and there's a human standing right next to you. There's a human standing outside of your house. There's a human standing on the street. There's a human somewhere in the city. They're all humans, and they are their own copy of the human data type. But the only thing that you're going to see is the closest one to you. So if there are a bunch of different humans, okay, you can only see the one that's standing right next to you. So you only see variables that are declared closest to you. Only see the variables with the same name that are closest to you. So the scope of a function is similar to the scope of an identifier declared outside any block. So some compilers initialize global variables to default values. So usually if you have a global identifier, you don't have to worry about garbage values. So it is the function of the compiler. Okay, so it is not the function of the language itself, but the compiler can choose to initialize variables, global variables. In C++, the way that we actually access global identifiers is with the scope resolution operator, which is the : operator. By using the scope resolution operator, a global variable declared before the definition of the function or a block can be accessed by the function or the block. Even if the function or block has an identifier with the same name as the global variable, we can still see that variable. You're kind of like looking over, and so somebody's standing next to you, and then you use the : that means maybe you can see somebody standing outside your house. You're looking over the person sitting or standing next to you. To access a global variable declared after the definition of a function, the function must not contain any identifier with the same name. The reserved word extern indicates that a global variable has been declared somewhere else. So you would use that keyword, or reserved word extern. Now, using global variables causes side effects. A function that uses global variables is not independent. If more than one function uses the same global variable, it can be difficult to debug problems with it, because you don't know which function makes changes to that variable, because it's global and everybody can see it. So problems caused in one area of the program may appear to be from another area. So global name constants have no side effects. If it's a constant, you just see it. It's kind of like a read-only. You're only reading it, but you do not changing it. So it's a lot safer if you're using global identifiers to place constant values as global, and then global variables, you need to be really careful with that. So static and automatic variables. Automatic variable memory is allocated at the block entry and deallocated at the block exit. By default, variables declared within a block are automatic variables. That's what we use in our for loop, automatic variables. So static variable memory remains allocated as long as the program executes. So global variables declared outside of any block are static variables. So how do we declare static variable within a block? Well, we need to use the keyword or reserved word called static. And that's what you need to do to keep that variable alive between function calls. So static variables declared within a block are local to the block, have same scope as any other local identifier in that block. So it's still going to be local to that function. Now when we have larger program and larger problems, it's a problem-solving methodology that you need to divide and conquer it. So sometimes you need to use a driver program, and that driver program is a separate program. It is to use to test a function. So if you have 15 different functions, you can just have one driver program test each function at one at a time. And a stub function, a function stub, is a function that is not fully coded yet. So basically it just returns a false value until you fully implement that function. Now when we're talking about function overloading, we create several functions with the same name but different parameter. Because the function signature is the name and the formal parameter list of the function. It does not include the return type. So the same function name, same parameter list, different return type is not a different signature for the function. So we keep the same function name, but we change the parameter list. And that's when we overload the function. So two functions are set to have different formal parameter lists if both functions have either a different number of formal parameters, or if the number of formal parameters is the same, but the data type of the formal parameter differs in at least one position. Overloaded functions must have different function signatures. What is a signature? Name and the parameter list. Okay. So parameters list supplied to a call to an overloaded function determines which function is executed. And we've seen that with the POW. Remember that we had the power of a number and we had a base and an exponent. And the base could have been float comma float, or float comma integer, or double comma double. So how does the compiler pick which function call to execute? Well, it depends on the parameter list. So if you call the function with double comma double, then you or the compiler calls the function that has the formal parameter list of double comma double. So in a function call, the number of actual and formal parameters must be the same. So C++ relaxes this condition for functions with default parameters. Okay, so you can specify a default parameter in function prototype. So when you have the prototype of the function, you can have a default parameter. If you do not specify the value of the default parameter when calling the function, the default value is used. All default parameters must be the rightmost parameter of the function. If a default parameter does have value is not specified, you must omit all of the arguments to its right. So default values can be constant, global variables, or function calls, and cannot assign a constant value as a default value to a reference parameter. Remember, reference parameter refers to memory address, and the memory addresses are controlled by the operating system, not by your application. So you cannot have a default value for that. Okay? But that's pretty much it. So that is your chapter 6. Okay? So let's go ahead and load up Visual Studio. And see what we can do here. Okay? So remember our steps. How do we create functions? So let's just create a simple hello world again. Okay, so at the beginning, when you're learning a function or how functions work, don't go overboard and make it too complicated. Okay, just make it really simple. Okay. So first of all, let me show you what do you mean by global variables. Okay. So let's say we have int. Let's just call it x is 5. Now that is outside of main, and I have only one function. So x is outside my function, for all the functions. So that makes it a global x. Now within my function, I'm also going to have int x, and maybe I initialize it to 50. Now what is that? That is my local x. Now if we want to display that, right, so if we do cout x, what is going to be displayed? Okay, so let's break the code right here. We launch the application. And how do we evaluate this? Well, who's standing closest to us? If I need to display x, the closest x that I can see to this statement is right here as my local x. But what if I want to see this global x? Well, they have the same name, so we cannot really figure out which, or the compiler cannot automatically figure out which x you need. So the rule is look at the closest one. But if I want to see the global, what we can do is use the scope resolution operator. Right? The scope resolution operator used will allow us to look over the variable standing right next to us, which is the local x, and now we are accessing the global x because of the scope resolution operator. Okay, so that's what it's talking about. Okay, so let's create a function. Remember step one? Step one is prototype. Okay, you're just going to do a void function, void. Let's call it print header, and let's receive x. Let's do another one. Let's go ahead and receive y. Okay, but let's give y a default value. Okay, so how do we call print header? Right. Print header. Put in the open parenthesis, and you can see that automatically it comes up with the IntelliSense, and you can see that it shows the default value because of our prototype. So in this case, how can we call this? Well, we can just call it with x. Right? and we don't have this squiggly line. It's not an error. But we don't have a print header function with just one parameter. But because we have a default parameter, and the default parameter is ignored or not sent as a parameter in the function call, it's perfectly fine because we're still going to be calling the function with x and y. It's just x going to be 50 and y going to be 5 by default. And if I say comma 500, in that case, I'm overwriting the default value, and instead of y equals 5, we're sending y equals 500. Okay, so well, let's go ahead and do step number 2. What is step number 2? Go ahead and implement the function, right? So step number 2, implement, okay? And here we have x and y, and we give it a body. We don't use the semicolon, right? We don't have to use the return because it's a void function. And let's go ahead and print out, let's say x. Let's just put in a little space and then print out y. Okay. So what happens if we just calling the function with x? What else can we call it with? What if we call it with the global x? Well, that's perfectly fine. What if we call this function and we overwrite the default and we call it with 500? Okay. So what's supposed to be the output when we calling the print header just with x? It should be 50 space and then 5, right? That's what the output's supposed to be. Always trying to figure out ahead of time what do you think the output's supposed to be, and if that's the output, then you understand the concept. Now, if we using the scope resolution operator, we should get 5 and then 5 as an output, right? X and Y, both of them are going to be 5. Now, if we're using x and 500, now x again is a local variable. Local variable is 50, and then the literal, the actual parameter is 500. Okay. So at that point, we call the application, right? And you can see we have 50 and 5, 5 and 5, and then 50 and 500. And here, within the function, we just displayed the global variable 5. Okay. So hopefully that helps you understand how the function calls work. But so far, how do we call these functions? These functions are called by value. Okay. Value means what? Well, let's stop the code after we call the functions, right? And let's go ahead and call or stop the code when we are in the function call. Okay. So we run it. Okay. Let's add another line here so we can actually stop within the function itself. Okay. Okay. So now we can stop in the function itself. So you can see that x and y. Right. So here's x and here's y. So x is 50. Why is x 50? because of the local variable 50. But why is y 5? We did not send 5, but 5 is received because the prototype shows what the default value is. So in the function we have x and y, 50 and 5. So we continue on. Now we are in the second function call. In the second function call, we call the function with the global variable, and that global variable is 5, and we did not have the second parameter. Because of that, we take the default parameter, so in the function we have 5 and 5. Next we call the next function. X is local variable x, which is 50, and then a literal variable 500. So 500 will be y. Now if we go next, you can see that x is still 50. Okay? So let's stop this code and maybe add a value. Maybe add the value to x. Okay? So what does that mean? We are changing the value of x in the function, and let's make little changes here so you guys can see it. Okay, so AB, let's receive it as A and B, and we are incrementing A, and we're just displaying B. Or just so you can see it, why don't we take away something from B? Okay. The main thing is that you can see that we are manipulating variables that we have received within the function. And let's not stop it in the function itself. So we can just see that we're calling the function 3 times. Okay. So we are manipulating the values in the function, but when we go back to the main function itself, you can see that 50 is still 50, or x is still 50. Right? Just because we manipulated A and B, what is A and B? Remember that x is linked to A and y is linked to B, right? Because of our function call, right? So here's x. X is the first parameter to the function, and then y is the second parameter, which in our case is just going to be B. Okay? But you can see that it is a copy. It's an independent copy, so as we are making changes to A and B, that does not affect x and y. So let's create y here. Okay, let's do y as 40. So instead of a literal variable, why don't we call this function with y, this function with y, and then this function with y. Okay, so now what's going to happen? X is local variable 50, y is 40, so it should display 40. X global variable is 5, y local variable is 40, x local variable is 50, and y value is 40. Okay. So now if we stop this and replay it, we are back in the main function, and you can see that x and y is still the same values. So just because x and y is linked to A and B, and we manipulate A and B does not do anything to x and y. Okay. So now what's going to happen if we need to make changes to x and y? Well, we need to make changes to x and y from the function. The only thing that we have to do is put in the ampersand. Okay, so the only change that we make is that we're putting in the ampersand in the prototype. Okay. Remember, if it's an ampersand, we cannot have a default value, right? Ampersand means the memory address. We do not control the memory address. So in this case, it is a reference to A, or a reference to whatever the value in the actual parameter is, and that reference is going to be stored in A and B. So now we're going to make a change in the actual implementation as well. Okay. So now we have an implementation. And let's stop the code inside the function call so we can see how that changes. Go ahead and run the code. And now you can see that A and B, so A is incremented, B is decremented. But look at the type of it. The type is not integer, but it's an integer reference. And this is an integer reference. So A and B is not storing 51 and 39 as a local variable that's only going to have the scope until this function is alive, but it is referencing the memory address in the calling function. Okay, so let's put a break over here. So when we continue and come out of the function, we came out of the function and we are about to execute the next line of code. So we are looking at x and y, and if you look at x and y is modified. So when we did not use the ampersand, we made a copy of 40 and 50, the values. But now we are referencing x and y in a different function. We're just calling it A and B. But any kind of a change that we make to A and B will change x and y value in main. So we continue on. We're back in the function. Back in the function, we have A is 6 and B is 38, but we are still in function print header. We go and continue with the code. Okay, and oops, I clicked it one more time. So let me just do this. So we're in the function. Back in the next one, let's put the break right here. So when we come out of the function, okay, you can see that the global value, right? The global value is changed to 6 because we send the reference to the global value. So that's the one that's changed. And then we send the reference to our local value, the local variable y. And now when you look at the local variable y, now it is reduced to 38, because this is the second function call, right? In each function call, we take away 1. And we continue, we're back in the function. A is 52, B is 37. So when we go back to the function itself, you can see that x is 52 and y is 37. Exactly the same values, but they A and B was when we were in the function. Okay? So this is really what you need to practice, and you do have to have a good grasp on this before you move on to any other concepts. Just make sure that you understand the difference calling the function by value versus calling the function by reference. And that's pretty much the meat, the main concept in this particular chapter. Okay, so we're breaking out portions of the code into functions, and if you can see it in this case because we have two references. We're changing two values in the calling function, so it's kind of like two return values, because in the calling function we are modifying the value of two different variables. Okay, so that's important to understand. Okay, as far as the scope of an identifier, right? So you can have, let's say, let's say for int I equals 0, I less than 3, I plus plus. Okay, and let's just do C out. We just print out the global variable. Okay. After that function, after that loop executes, right? Let's just print out C out I. Okay. And now we get an error message and it says, what do you mean by I? I is undefined. Well, why is I undefined? Because I was defined in this block when we created the for loop, right? So I is local to the for loop. Now if it's only one line, we don't have to put in the curly brackets, but it's still going to be the body of the for loop, right? So I is declared within the for loop body. So when we exit out of the for loop, I is gone. Now if we are inside the for loop, right, we can use I because we are inside a block. And inside the block we have an I or a variable declared. But as soon as we exit the block, I is gone, is not visible anymore. Okay? So that kind of covers your global variables, function calls by value, function calls by reference, scope of the variable. So this small little example right now contains a lot of concept out of this chapter. So practice it. Don't go into more detail. Okay? When this makes sense, then go ahead and look at the assignment and work on the assignment. Okay? But that's pretty much it. So next time we're going to be talking about moving on, and we're going to talk about chapter 7. See you next time.